Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred, and I'm so excited to bring you live and in stereo to Unit 5 mini lesson number 3 about combining like terms. Today, we're going to take what we learned about the distributive property and expand on that a little bit. Okay, we're going to take that distributive property and some other things, and we're going to talk about simplifying variable expressions so that all the like terms are together. Okay, so your learning goal by the end of the day you should be able to explain to a friend how to combine like terms. Let's get ready to get started by writing this as our third entry in the table of contents. This is Unit 5, mini lesson number 3 on combining like terms. And tomorrow's date will be December 14th, 2017. So here we go. During mini lesson 1, we talked about variable expressions. Tell Edpuzzle what you think a variable expression is. That's right, a variable expression is a math sentence that has variables, numbers, and operations. And by operations, I, of course, mean addition, subtraction, multiplication, and division. We also talked about constants on Tuesday. Constants are numbers that do not change, like 7, 18, 97, 164,964,232. All those are constants. A variable is a letter or a symbol that takes the place of or stands for a number. Usually you see like X or Y or Z or J or C or B or 7. You don't see 7. That was a joke. But you do see the letters and symbols that represent numbers. So today we're going to talk about combining like terms. Look at that. There's the word term from our mini lesson title. In a variable expression, all the terms are everything that is separated by an addition sign or a subtraction sign. So in this example right here, A would be its own term, 2B is a term, 5C is a term, and 6 is a term. And all those are different terms because they are all separated by addition signs or subtraction signs. Okay, we talked about this before, but if you have a number right in front of a variable, right next to it, like that 2 or that 5, there's a word for those numbers, and they're called coefficients. It just means that that number is being multiplied by the variable. So, with all that in mind, since terms can be separated by addition signs or subtraction signs, a term can be one of 3 different things. A term can be a constant, like 19, or a variable, like m, or it can be a variable and a coefficient multiplied together. Those are the only 3 things that terms could be: constants, variables, or variables with coefficients. Okay? Today we're going to talk about combining the like terms. So look at that. There's another word added from our mini lesson title. What are like terms? Well, all the constants, all the numbers, are like terms. You can always combine constants if you have a long expression. Like terms have the same base with a raised power that is the same. So for example, if I had 2a plus 3a, that doesn't say 2, that says at 2a plus 3a plus 9a plus a, I could combine all those terms together because they all have the same base and the same power that is the same. 2a plus 3a is 5a, plus 9a is 14a's, plus a would be one more a, 15a's. All those things would combine to 15a. All these b terms could be combined, all these c terms could be combined, all these xy terms could be combined, and all these x squared terms can be combined because they have the same base and the same power. Okay? What I'm going to ask you to do now is try to fill out that chart by separating all the like terms in each column. Edpuzzle can't really ask you how to do that because it's so long and complex, but I'm going to show you what I got when you're done. So pause your video and try to separate the x terms, y terms, constants, and b terms into this chart. Hopefully you said that 3x, 5x, 4x, and x were the x terms. Hopefully you said that 9y, 6y, and y were the y terms. Hopefully you said that 7, 6, 3, and 5 were the constants. And hopefully you said that 4b, 10b, b, and 2b were the b terms there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I found all 15 terms, put them in my chart, x terms, y terms, constants, and b terms. Okay? That's great. If you know how to separate the like terms, then you should be able to combine the like terms. Here's how you combine like terms. There's a couple steps. The first thing you want to do is use the distributive property if it's there. And then you want to identify all the like terms. And when you try to combine them, you're going to include the sign, the operation that's in front of them when you try to combine them. So for example, example 1 says 3 times x plus 3 plus 2x minus 8. You need to use the distributive property there. 3 times x is 3x, and 3 times 3 is 9, plus 2x minus 8. Then, here's the process I'm talking about figuring out what the like terms are. I'm going to use color coding to do this. So I see 3x. The only other term in there that can go with the 3x is the 2x. So I'm going to put the 3x and the 2x together. 3x plus 2x. See this plus sign in front of the 2x? Okay, that tells us that we're going to add 2x to 3x. 3x plus 2x is 5x. Okay, plus 9. So I see this plus 9. The 9 can go with the 8. But the 8 has a subtraction sign in front of it. So because the 8 has a subtraction sign in front of it, that's what I mean when I say include the sign in front of the term. Positive 9 minus 8 is positive 1. So I'm going to write it there in my final expression as 5x plus 1. And now, y'all, now I have a simplified expression. This is the simplified expression of 3x plus 9 plus 2x minus 8. That's the simplified expression there. So you're done with example 1. Example 2, I'm going to do this one for you too. Example 2, you're going to distribute 2 times 5 is 10 plus 2 times 6y would be 12y. So this is the distribution part right here. Okay. Plus 2 minus 8y. You can copy and paste the rest. What can you combine? Well, you can combine the 10 and the 2. Positive 10 plus positive 2 would be 12. And you can combine the 12y minus 8y. So I got positive 12y because of the plus sign, minus 8y because of the minus sign. Okay, and 12 minus 8 is 4y. So my simplified expression there would be 12 plus 4y. That's the simplified version of that expression. Ed Puzzle is going to ask you to do number 3, and then that's going to be all for Ed Puzzle today. Hopefully you did number 3. You got 7a plus 5b plus 7. That's the simplified expression for number 3. 7a plus 5b plus 7. Thank you so much for watching this video. Tomorrow in class, we'll work on some of these practice problems on the back. But for now, you just need to make it a great day or not. The choice is yours. Of all my students I've ever taught, you are one of them. Have a great day. Thanks.